To solve word problems, we're going to translate sentences into equations. In doing so, we're going to define a variable, identify the operations that are being used, and the order in which they are applied. So if we look at example 1, not a lot of context to this problem, but when a number is doubled and then increased by 5, the result is 37. I want to find what this number is. To solve this problem, I'm going to let n equal the number I'm solving for. And if I now look to my sentence, a number is doubled and then increased by 5. So the two operations that appear within the sentence are, when I see doubled, I see multiplication, in fact multiplication by 2. And then increased by 5, I'm thinking, well, we're going to add the value 5 somewhere in our equation. And the order in which it appears would be, I'm first going to double it and then add 5. So that's how I'm going to use these and the variable n. The first part of this sentence is if I double a number and increase it by 5. To actually get an equation, I have to have an equal sign, and as I read further, I see the result is, so I can put equals and 37. So let's solve this equation for n. I'll subtract 5 from both sides, which gives me 2n is equal to 32. And then I'll divide both sides by 2, and I get n is equal to 16. So I translated this sentence into an equation and then used all of our methods to isolate the variable. So in example 2, similar ideas, it's just a slightly more complicated question. When a number is decreased by 11 and then divided by 2, the result is 3 less than the original number. So again, starting with defining a variable, I'm going to again let n equal the number I'm solving for. And I'm going to start to write my equation. So we have this number, it's being decreased by 11 and then divided by 2. So this time, I see this decreased is going to be subtraction. We're subtracting 11. And then divided by 2, somehow I'm going to have like a division symbol in there and divide by that value. And the order in which it happens is going to be this first and this second. Here's what the equation should look like. I first want to take my number and decrease it by 11, but then I'm taking that entire thing and dividing it by 2. This definitely works. I apply this first, and then dividing by 2 is second. So it further says the result is, so again I can put my equal sign, and then it says 3 less than the original number, which is, again, the variable n. This is a pretty easy place to make a mistake. This 3 less than the original number. A mistake would be to go 3 minus n. This is going to be wrong. Even though the 3 appears before the number, this is not 3 less than n. It would actually be n minus 3. So this would be correct. So you have to be careful with the language in the sentence. So you can't just simply place the numbers and the variables in the order which they are in the sentence. This is 3 less than n. I'll put that over here to complete my equation. So here we go. I have this equation, and the goal is to solve for n. I see there's this 2 here. I'm going to multiply 2 to both sides to cancel this denominator. So that is, I get 2 over 1 multiplied to the left side. And that is equal to, I don't need a fraction on the other side, so I'll just put 2. And that's being multiplied to n minus 3, the whole thing, so I'll just put some parentheses. The reason I was doing this is to cancel this 2. And you could even be careful and put some parentheses around that n minus 11, but everything over here is just a 1, so you don't even really need the parentheses anymore. I'll continue my work. The whole left side is n minus 11. And if I distribute the 2 into the parentheses, I get 2n minus 6. To solve for n, I think I will add 6 to both sides, which gives me n minus 5 is equal to 2n. I'll then subtract n from both sides, and I get negative 5 is equal to n, or if you prefer, n is equal to negative 5. And that is the final answer. Let's use these ideas in a question that has a little bit more context. So for example 3, a local gym offers a month-to-month membership. However, if you pay upfront for a year, you receive a $35 discount. So if you pay $445 for the year-long membership, what is the month-to-month fee? A good place to start is, just like in the previous two questions, is to define your variable. We could call it, n or x, but I'm going to let m equal the monthly fee. X would be fine, but I thought month, m, why not? To set up my equation, here's what I know. Whatever your monthly fee is, if you want to know how much you pay in a given year, you would multiply this by 12. So I'm going to put 12m into my equation. And if for the moment I ignore this discount of $35, I know that the answer is going to be 445. But if I then go back to put this discount in, I know in some way I'm subtracting $35. In fact, if you multiply the monthly fee by 12 and take away $35, this would represent my equation. Let's think about why this makes sense. So you go to the gym, they have a monthly fee, you multiply it by 12, that would be your yearly fee, and then they say, oh, wait a second, but if you pay it all at once, we'll take $35 off of this bill. And we know that you paid $445. So this side was set equal to this side. I can now ignore all the context of this problem and just focus on solving this equation. Very easy to do. I can add 35 to both sides and then divide both sides by 12. All right, so if I first add 35, I get 12m is equal to 480. To get m by itself, I would divide both sides by 12. And 480 divided by 12 is 40. And in the context of this problem, that is $40. That's the monthly membership for this gym. But if you didn't pay the month-to-month, you would take off $35 and really only pay $445.